In this video, I'll talk about cones, and it's all in my book, Ellen's Guide to Perspective, on Amazon. Here are some examples of cones. We have a cloth fold, an umbrella, a shell, a pine tree, and a pine cone. Now, a cone is composed of 2D forms, two-dimensional forms, just like a cylinder. One of the forms is an ellipse, and the other are two lines that go to the apex. These are two-dimensional forms that create a three-dimensional cone. And also, like the cylinder, the minor axis of the ellipse is contiguous with the axis of the cone. The side of the cone is tangent to the ellipse, and the tangent point lies behind the major axis of the ellipse. If it went to the major axis of the ellipse, then it would enter the cone, and that would be wrong. So this is a wrong drawing. Now, when we're looking at it from the side, this tangent point is pretty close to the major axis of the ellipse. But when we're looking from an overhead view, this tangent point is very far away from the major axis of the ellipse. Imagine we're looking at a Hershey's Kiss from the side view and from overhead. So what's the difference? This one looks more like a cone because we see its sides. The tangent point is close to the major axis of the ellipse, and the ellipse is relatively narrow. For the overhead view, we see less of the sides, so it looks less like a cone. The tangent point over here is far from the major axis of the ellipse, and the ellipse is quite round. We can see around a lot of it. The hard part is relating the roundness of the ellipse to the length of the sides of the cone. So to do that, put the ellipse in a trapezoid and find its perspective center where the diagonals cross. So it's this red dot. Then draw a line through the red dot to find these two green tangent points. And that's going to be where the sides of the cone pass. So the sides of the trapezoid are contiguous with the sides of the cone, both part of this large triangle. And again, as I said, this perspective center is behind the major axis of the ellipse, especially in this case where this triangle flattens out. How do we draw a horizontal cone? Well, you can fit it in a box, but we need to have the tip on the ground. So when the tip moves down, the ellipse has to circle around because the minor axis of the ellipse has to be contiguous with the axis of the cone. You could envision putting a triangular prism here to support the base, or alternatively, you can enclose the ellipse in a trapezoid where these lines, the blue and this red line here, are perpendicular to the axis of the cone, like I did with this meat thermometer. A truncated cone looks like a triangle with the top taken off. As we look at it from a bird's eye view, the top and the bottom become increasingly round. And initially they're connected by lines from the cone, but at some point the top overlaps the bottom and increasingly comes toward the center of the bottom ellipse. This trash can is an example of a truncated pyramid, or if it were rounded out, a truncated cone. So how do we draw it? We find the diagonals of this rectangle and erect a vertical line, and then at a certain point, connect this top to each of the corners. So now we have a pyramid. Then decide where you want to cut off the pyramid and draw another rectangle touching each of these four green lines and parallel to the rectangle below. Find its center and place the ellipse there. And interestingly, the ellipse has a vertical minor axis because it's contiguous with the axis of the trash can. So even though we're viewing the trash can from the side, this ellipse is horizontal. In fact, it would have the same orientation as the top of the can inside this box. Here's another garbage can that resembles a truncated cone, but this time the openings are on the side. And what's interesting is that you really only know that it is slanting by looking at the sides, not the front or back that look vertical. To draw this twisted cone, start with 2 ellipses and number one of them clockwise and the other one counterclockwise, and then connect like numbers together. So number 3 here is connected to number 3 up there. And then you get this interesting form. These 2 conical pears are too close together. And how do we know that? Draw the elliptical diameter of each one. And if they intersect, then they are too close because they can't occupy the same space. A pyramid on a box is a common structure in architecture and can be converted to a cone. To draw this, find the hidden rectangle at the base and find its center using diagonals, and erect a vertical line from that center, and this line goes to the tip of the pyramid. As you increase the number of sides of a polygon, it increasingly looks like a rounded cone. So this octagonal pyramid looks more like a cone than the pyramid I just showed you. You can put the octagon in a trapezoid, so these purple dots divided into a large front side and a smaller back side. To convert this into a pyramid, just raise a vertical line and at the top connect it to all the corners of the octagon. So now we have the 2 widest sides of this 3D figure in front. To draw a shadow of this pyramid, or if it were rounded out, a cone, start with light passing through the apex and find where it meets the line from the middle of the base. Then find the 2 shadow lines that are tangent to the bottom edges of the pyramid and meet at this point on the shadow. If there's a wall in between, draw the shadow the same way as if the wall didn't exist, so we can get these 2 lines. And then when these lines hit the wall, they go up to meet the light at the tip of the shadow. Finding the shadow of a pyramid pointing downward like this is more challenging. We have the light source up here, and vertically below is the vanishing point for the shadows. And we need to form seats for each of these floating corners. So for this seat, it goes down until it intersects a line from the vanishing point. And we continue that until we find the intersection of the light from the top of the seat going down. So this will be a point on the shadow. Similarly, we can draw a line through this seat and continue it until it intersects the light from the top of the seat. In my next video, I'll talk about drawing some cylindrical shapes, and please remember to subscribe.